Hi, welcome back. This is Professor Ridge, and today's lesson on section 3.4, Systems of Equations and Three Variables. So I'd first like to talk about the techniques from two variables, system of equations, two variables from 3.1 and 3.2. We could actually extend all three of them into three variables. So we can graph, we can do substitution, we can do elimination with just some slight modifications. However, graphing in three variables, so note, three variables were in three dimensions. And if I had an equation, three x plus 2y plus z equals 5 represents a plane in a three-dimensional space. So from 3.1 we were in a two-dimensional space, x and y, and you have your xy axis, or which is a plane. In 3 space, in 3D, you have x, y, z, three variables. That's 3 dimension. And the way you do is you take your xy axis and you actually flip it sideways. So your x-axis is still going horizontally, but now your y-axis is going to actually come out at you. So, and the vertical axis is going to become the z-axis. So like that. So if I wanted to plot the point 1, 2, 3, for instance, you would have to go 1 unit. So just imagine, like, if you're in your room and pick a corner and let that be the origin, and if you were to move along one wall 1 foot and then come out 2 feet, so somewhere right about there, and then go up 3 feet, that would be the point 1, 2, 3. So now it's a location in space, in a three-dimensional space. And to graph that would be pretty hard, because we're graphing on a paper here, which is two-dimensional space, so we're really doing like a shadow of it. So that's the point 1, 2, 3. And again, that would be pretty hard to visualize, to draw it. Now, back to what I wrote up here, the equation represents a plane. So if I were to graph this onto this space here, again, that would be pretty difficult to do. And if you have two planes, so here's a plane, and I draw another, and the planes extend in all the directions on a flat surface forever, so that's just a portion of the plane. And if I had another plane, maybe like this, okay, that's coming out at me, so this should be dotted here. Two planes can intersect at a line right there. If you have three planes, they can intersect at a point, they can intersect at a line, they can intersect at 3 different spots, not all at the same time, so lots of stuff can happen in 3 space. Okay, so graphing wouldn't be a wise decision, although you could probably do it with some computer models, but for our purposes we want to kind of stay away from graphing. Substitution, you could also again extend that. You could solve one of the equations for a variable, plug that into the other 2 equations, and then go from there. But actually the method that lends itself the best for 3 variables is the elimination method. So let's look at an example. Okay, so we're going to solve this system of equations. Now what I want you to do is get used to doing this, labeling it. So we're going to label equation 1, 2, 3. Okay, so first step is we're going to add the equations together or multiples of the equations together to eliminate a variable. So it's that same technique. So let's take equation 1 and equation 2, add them together, and we're going to eliminate z. That's my goal. And we're going to get 3x, and y gets eliminated and z gets eliminated, and we'll call that equation 4. Call result equation 4. Okay, step 2. Okay, so take the equation you haven't used yet and either of the other two equations and eliminate the same variable. So we want to eliminate the same variable and use the equation we haven't used yet. Okay, so we've got to meet both those conditions. So to get equation 4, we used 1 and 2, so we have to use equation 3, and we have to get rid of z, because I was eliminating z. Now actually in this one, so let's see, equation 3 is negative x plus 5y minus 3z, and I'm going to use equation, let's use equation 2 and get rid of z, and I'm going to times it by 3. So that's going to be 6x minus 3y plus 3z equals 9. And we're going to add those together, get 5x plus 2y equals 11. We'll call that result equation 5. Okay, so step 3, take equations 3 and 4 and eliminate another variable. So equation 3 is 3x equals 3, and 4 is 5x plus 2y equals 11. Now note, equation 3 has y already eliminated, so this step's done for us. So I can skip this step basically, and we'll call equation 3 is going to be my equation 6. So this is saving us a little work. Okay, so our next step, solve that resulting equation from step 3, solve equation 6. Okay, so here's step 4. We're going to solve it. So x equals 1. Okay, now we're not done. So now step 5, we're going to plug that result in. Into either, and we're going to kind of go backwards, but go back up, plug it into either equation 3 or 4 and solve for another variable. Okay, so let me see if I can kind of squeeze. This is step 3 or step 4. I'm going to do step 5 over here. So I'm going to plug x equals 1 into equation 3 or 4. Well, 3 I can't use because it only has x, so I have to use 4. So I'm going to plug in 1 for the x and solve it for y. So subtract 5 from both sides. That's 6. Divide both sides by 2. So y equals 3. So again, remember our solution is going to be a point, an x, y, and a z. So now, let's go to the next page. Okay, so step 6 is now we're going to take the results, the two variables that we just solved for. So plug result from step 4 and 5. Plug those into equation 1, 2, or 3 and solve for the remaining variable. Okay, so let's choose equation 1, which is x plus y minus z equals 0. We're going to plug in, we know x is from step 4, x is 1. We know from step 5, y is 3. So we're going to plug those in to equation 1, 2, or 3. I chose equation 1. You could choose 2 or 3, doesn't matter. So we're going to put 1, 3, solve it for z now. So you get 4 minus z equals 0. So z, add z to both sides, z equals 4. Again, it's not really a step, but I like to write it out. Make sure you write your solution. As a point, unless it's one of the special cases, which we'll talk about in a little bit. So with point 1, 3, 4, put it in my solution set, and there you go. Now, if I wanted to check this, or if I asked you a question like, is the point 1, 3, 4 a solution to the system, just like with two variables, the way you would check is you would plug it into all three equations. So you're going to, we got x plus y minus z, does that equal 0? Plug it in your calculator, do it in your head. 4 minus 4 is 0, check. Equation 2 is 2x minus y plus z, does that equal 3? So 2 minus 3 is negative 1 plus 4 is 3. And then the third equation, negative x plus 5y minus 3z, does that equal 2? So you can punch that in your calculator, do it in your head. So let's see, I got negative 1 plus 15 is 14, minus 12 is 2. Yep, so it checks out. Okay, so again, that's how you check. You punch it in your calculator or do it in your head. You check it in all three equations, make sure they all work. Let's do another example. Okay, so again, label the equations 1, 2, 3. So this is number 14 from the book. My first step is get rid of a variable. So let's get rid of y. I'm going to eliminate y. Oops, eliminate y. So let's take equation 1, equation 2, just add them together. gives me 3x plus 9z equals 27. Call that equation 4. Now, step 2, I'm going to use the equation I haven't used yet, which is 3, and get rid of y. Okay, so let's see. If I get rid of y, I'm kind of looking, so if I look at equation 3, it's negative y. If I look at equation 2, it's positive 3y. So what would be a common denominator to cancel those y's out? Or a common multiple, I should say. And the answer is, if you take equation 3, multiply it by 3, both the y's will be 3y. One will be positive, one will be negative. That's what I'm looking for. So for equation 2, we can leave it alone. X plus 3y, 8z equals 22. 3 times equation 3 is 3x minus, oh, we got to times it by 3. So it'll be 9x. You got to times everything by 3. And again, that's a reason that habit is a good habit to write it down what you're doing, so if you forget, you can kind of check. So I got 3, that's 10x. So this is going to be equation 5. 3's cancel. You get 14z equals 58. Okay, step 3. Take equations 4 and 5 and eliminate another variable. Well, I don't know what's wrong with me. So let's eliminate. Okay, so we'll take, we want to get rid of, let's get rid of x. So if we take equation 4 times 10, because we want LCM for 3 and 10, which will be 30. So I'm going to take equation 4 times 10 and get 30x. Now you got to do it to the whole equation. 90y, 270. Equation 5, I want a 30x, but a negative 30. So I'm going to do negative 3 times 10. It's negative 30x. So you can see that's going to cancel my x's. But now I got to do negative 3 times the whole thing. So 14 times negative 3 is negative 42 y. And 58 times negative 3 is negative 174. Combine those equations, that will give me equation 6. So the x's go away. That is 48y equals 96. Now, step 4, solve equation 6. So we're going to divide both sides by 48. So y equals 2. Okay, so that's step 4, I mean. Step 5, we're going to take this result, y equals 2, and plug it into equation 4 or 5. So let's plug it into equation I'm sorry, I messed up. This is 38. These are not y's, they're z's. I was having trouble there. It's like, where's the y? So it's not y equals 2, it's z equals 2. Oops. So that would help. Okay, so now I'm going to plug it into equation 3 or 4. Let's plug it into 4. The numbers are a little smaller. Plug z equals 2 in for z. Okay, so 9 times 2 is 18. Subtract 18 from both sides. You get 9. Divide both sides by 3. We'll subtract 18. Divide both sides by 3. X is 3. Okay. Now step 6. We're going to plug the result from step 4 and 5. So x equals 3, z equals 2 into equation 1, 2, or 3. So we're looking for y. I guess we'll use equation 3. 3x minus y plus 2z equals 12. So we're going to simplify this, solve it. So 13 minus y is 12. Subtract 13. Divide both sides by -1. So y is 1. And then, so that's step 6. And then step 7, we're going to write the result out. It's the point x is 2. Oh, I'm sorry, x is 3. Y is 1. Z is 2. And again, if I want to check, I plug all 3 points into all 3 equations. I mean, all 3 variables into all 3 equations. And see if they work. So let's see. 2 times 3 minus 3 times 1 plus 2. Does that equal 5? So 6 minus 3 plus 2. Check. And then 3 plus 3 times 2 plus 8. Oh, that should be 1. 8 times 2, does that equal 22? So it'll be 3 plus 3, 6 plus 16 is 22. Check. And then the last one, 3 times 3 minus 1 plus 2 times z is 2. Does that equal 12? So we got 3 minus 1, or 9 minus 1, that's 8, plus 4 is 12. Okay, they all check. Alright, so on to some special cases. Okay, so look at number 18. Again, label 1, 2, 3. Step 1, let's get rid of the variable using 2 equations. So let's get rid of x this time. So if I take equation 1 and 2, eliminate x. Let's see, I'm going to take equation 1, equation 2, times it by -4 to get the x's to cancel. Remember, you got to do -4 times each term and the constant on the other side. We add those equations together. That gives equation 4. So we get 13y minus 7z equals 49. Step 2. Let's take equation 2 and 3. So I'm going to take equation 3. 5x minus 2y plus 3z equals 5. And equation 2, I'm going to times it by -5, which will give me -5x, positive 15y, positive 10z, no, negative 10z equals positive 40. That will get me 13y minus 7z equals 45. Now step 3, I'm going to get rid of another variable using equation 4 and 5. So let's eliminate z. So I'm going to do -1 equation 5. Leave 4 alone. So -1, so it's -13y, positive 7z, -45. And here you see that both variables are eliminated, and now we just have a number sentence. 45 minus 49 minus 45 is 4. And this is not true. So just like with two variables, if you get an equation where the variables fall out, if the statement is false, so we just have numbers, no variables, 0 equals 4, that's false. That's always false. I don't know what I was writing there. No variables are in the equation. So you ask yourself, is it true or false? Well, this is false. It's always false. So just like we did with two variables, same thing here. No solution. No solution. Okay, if it was true, then we would have said there's an infinite number of systems, so the systems are dependent. Now, there's a lot more that can go on in three systems than in two, in 3 dimensions than in 2 dimensions. So there's a lot of different ways that you can have dependence. So basically, you're going to learn more about it in college algebra, but so for right now, if that was a true statement, you would just say the systems are dependent and leave it at that. Or you can say there's an infinite number of solutions. But if it's false, you just say no solution. So same idea. Alright, I get a lot of questions on problems like this where we still have 3 variables. They're m, n, and l, m, n. And what happens is basically there's missing variables in each equation, so it actually cuts down your work. So we still go through the same steps. Step 1 is you want to take 2 of the equations, eliminate a variable. So if I take like 1 and 3 and eliminate L, so let's see, this times the top one by -4, so you get -4L plus -4m equals -28. Equation 3 we'll leave alone. Now be careful, those don't line up. Equation 4, they're not like terms. So the L's cancel and you get -4m plus n equals -23. Now step 2 is we got to use the other variable equation. We got to use equation 2 and eliminate the same variable. But since 2 already has L missing, that step's done for us, so that becomes our equation 5. So we don't have to do anything with it. It just becomes equation 5. Now, step 3, take equation 4 and 5 and eliminate another variable. So if I take, let's get rid of n, so we'll do 2 times -2 times 4, which is 8, minus 2n, it's 46. 5 we're going to leave alone. That'll give me equation 6, which is 11m equals 55. Let's solve it. So 11m divided by 11. So m equals 5. Now I'm going to take m and plug it into equation 4 or 5 to get another variable. So let's plug it into 4. So that's negative 20. Add 20 to both sides. So n is negative 3. Now we can take equation 1, 2, or 3 to plug in these two numbers to get the remaining one. But see, you got to kind of think about it. What's missing? It's L, M, N, right? We're looking for L, M, N. We know M, we know N, so we just need we can only use an equation that has L in it. So I can't use equation 2. There's no L there. So I can use 1 or 3 only. So let's use 1. L plus M equals 7. And I'm going to plug in M, I know is 5. There's no N in it, so I don't have to worry about it. So L is 2. And then my solution would be 2 LM is 5, N is negative 3. Remember, it's alphabetical order unless you're told otherwise. There you go. Okay, so that concludes the lesson for 3.4. And go to my math lab, complete the assignment there, and I'll see you next time.